So here we go. I have got my trusty homework kit. I have a black pen, a highlighter, a calculator, a pencil and a ruler. That's my trusty homework kit that I need to answer questions with. I might not need all of these things, but I'm definitely going to need a black pen and a highlighter. Because to make sure that I'm reading the question, which is really critical to being able to answer it, I'm going to highlight some stuff. So I've got this drawing below, shows a section through part of a kidney. So I kind of look at this diagram and I'm seeing a bundle of stuff with a gap around it, and then these sort of circular structures lined with cells, which already makes me think that what I'm looking at is Bowman's and the glomerulus. So before I even start answering a question, I'm looking at that thinking, that's Bowman's capsule and the glomerulus, and I need to label A, B and C. So I'm now going to look more closely at the diagram. So B hanging in the middle of this gap, so we know that our gap from all the microscope activities we did is Bowman's capsule, which means that the thing dangling down in the middle is the glomerulus, and surrounding that we've got all those tubules, but I'm not sure which is which, and the diagram's not very clear and I can't see a brush border on anything, but some of them surely must have. So I'm just going to call that a convoluted tubule. Now when I was marking this, what I did notice is a lot of people put VCT, DCT. This is rubbish. You've made that up. That's an abbreviation that you've made up for your own convenience. You may well have seen it written on the board. We've made that up for our own convenience. In an exam, there's no way ever that you should be abbreviating. So, part 2. From which region? Now there are only 3 regions. This is the gross structure, isn't it? It can be in the cortex, it can be in the medulla, or it can be in the pelvis. And if we've got glomeruli, this is on the outer layer, so that's the cortex. And then there's one without a dotted line, and you do need to read these, and this is the purpose of the highlighter. Draw an arrow. Okay, I'm going to draw an arrow on the diagram to show where I would expect to find podocytes. So what do I know about podocytes? Podocytes are those little clingy cells around the outside of a glomerulus. So I'm going to draw my arrow. I'll use a ruler because, you know, it's always nice to be neat. The examiners certainly appreciate it when they're reading stuff off screens. And I'm going to put an arrow because I've been told to, and just to be on the safe side I'm going to put what it is, podocyte. So, super duper. Explain. That means I've got to give a reason. Give a reason how cells of the proximal convoluted tubule, so I'm not looking at the distal one now, just the proximal one, are adapted to carry out their function. So their function is selective reabsorption. That's the function. So what do I know about the proximal convoluted tubule cells? Well, I have a feeling that they're that kind of thing, and they've got the mitochondria in. So what do we call those? So they have microvilli to increase surface area for absorption, because that's what they're doing, that's their job, and mitochondria to provide ATP for active transport. So the way that works is, of course, the sodium ions are actively transported out of the cell into the basal channels, and then there's a low concentration in the cells, and they pull the glucose in with them. So the table below shows typical values for some important substances found in plasma, filtrate, and how much of each is reabsorbed, so how much ends up in the urine. And we've got water, protein, chloride, sodium, bicarbonate, glucose, urea, potassium. Okay, so before I look at the numbers, I'm going to see what do I need to do with it. Name. 2. And it's emboldened that are 100% reabsorbed. So what do they mean by that? They mean, well, you filtered it out, but then you've taken absolutely everything back. So there'll be nothing left at the end in the urine. So I'm looking for 0 in the urine. And I've got one there and one there, which relates to protein and glucose. So I'm not going to put anything that's not on the table. That would be ridiculous. So for example, I wouldn't put amino acids just because I've got that in my notes. I'm going to use the stuff on the table that I've been given to look at. Okay, super duper. Oh, hey up. Here we go. Calculate. The C word. Calculate. Percentage of water reabsorbed. So I'm going to look down my reabsorbed column and water. I've got 179 units reabsorbed, but I had 180 in my filtrate. Always percentages, unless you're doing an increase or decrease, is the little number over the big number, and then you just multiply by 100. I'm going to put those numbers into my calculator. 179 divided by 180 equals times 100, 99.44. And I'm thinking that to 1 decimal place, they haven't told me, but I'm thinking 1 decimal place will be enough. There's just a string of 4s after that. Okay, so what else have we got? Oh, calculate another percentage. Calculate the percentage of urea. So now I'm looking along that column there. My highlighter so it doesn't obscure it. Filtered out of plasma. So that's the filtrate column again, which is excreted in urine. So in the urine column. So plasma and urine. So my two numbers now are 53 for the filtrate, 25 for the urine. Apply the principle. 25 over 53 times 100 equals 25 divided by 53 equals times by 100. I've got 47.16, so I need to round this one. I've got 169, so I'm going to round to 1 decimal place because that's what I did there. So the 6 then moves to a 2, makes that one a 2, 47.2%. They're not going to be too irate if you round that to 47.17, but they won't let you round it to 47.16 because that would be totally incorrect. Okay, so what have we got here? We've got diagrams of the nephrons of 3 different mammals. So this is the loop. E is the collecting duct. And we've got 3 different sizes. We've got a long, a medium and a short. X, Y, Z. Okay. Turn over. Name the parts D and E. D, loop of Henley, not with a Y, not Henley on Thames, and E, collecting duct. Describe how. Part D uses, we've got to comment on two things. We're only talking about the loop, part D. Describe diffusion. Active transport diffusion to get an osmotic gradient. Okay, so what do I actually know? Active transport. So in the ascending loop, that's the one I'm most confident with. In the ascending limb, sodium ions and chloride ions are actively transported to the medulla. Now I'm now going to have to go and look something up because, you know, I don't actually know about this diffusion thing, and I kind of want to write about osmosis, but they would have said osmosis if they'd wanted me to write about that. So I'm going to go to Marianne Issen's textbook, and I'm going to look it up. And what she writes in her textbook is that in the descending limb, ions diffuse into the filtrate. So that's quite interesting. Okay, so name the process by which absorption of water takes place from the surrounding tissues. So water movement, well, it's going to be osmosis, isn't it? It's a process. Osmosis is a name. Which hormone? I only know one hormone to do with the kidney, and it does. I know it changes the water permeability of part E, but I'm a little bit relieved that they're not asking me how it does that. So ADH, or I could have written antidiuretic hormone, but actually in this case ADH is the abbreviation. That is a standard abbreviation for this. So I don't know why I was given these diagrams, because I've not used them yet. So hang on a minute. The table shows urine concentrations, nice, from mammals in different habitats. So we've got the domestic cat, mesic, don't know what that means. Kangaroo rat, xeric. So this is the most concentrated, 5500 urine concentration. Beaver, freshwater, least concentrated. I'm thinking these habitats have something to do with water then. So what does it say? Xeric habitats. Xeric means low, limited availability of water. So I'm just going to write that in, low water. So what do I know about that we would need to not be losing a lot of water? So we're going to have most water reabsorbed with a low volume of urine and a high concentration. Now again, vol is not a standard abbreviation for volume, conc is not a standard abbreviation. These are my notes to help me answer the question. If I was writing about concentration, I'd have to write it in full. So let me look. So use the information in the table there, so I've looked at that, to identify the mammals to which the nephrons in the diagram. Here we go, nephrons in the diagram. So, most water reabsorbed, I'll be looking for something where it's going through the medulla a lot. Long loop of Henle, big salt concentration gradient, being able to collect more from the collecting duct. So X is going to be my driest one, longest loop, driest environment. So X, most concentrated, lives in a low water environment, kangaroo rat. Still don't know what mesic means, but it's got a medium concentration urine. Beaver will be the shortest one because it doesn't need to, because it's living in fresh water. Beaver, so by default my domestic cat must be the middle one. 6. Describe the relationship. So I'm going to say as something gets longer, this and I'm looking at the habitat and the length of the loop. So now it's limited availability of water. Habitats with limited availability of water. I don't want to put hot or dry, just in case I'm not right with that. Use the words on the paper. Habitats with limited available water. The loop of, can't spell, loop of Henley. What am I commenting on? The length is longer. So that's that. Very good.